Hey, do you want to boost your productivity in OpenShift? Imagine spending less time troubleshooting and digging through documentation and more time delivering value. If that sounds good to you, you're going to love OpenShiftLightspeed. If you haven't heard about OpenShiftLightspeed before, the simplest way to think about it is as a virtual assistant for OpenShift, integrated right into your web console. Now let's explore what this assistant actually does and the value it brings. OpenShiftLightspeed is all about guidance and assisting with troubleshooting and investigating cluster resources. The ultimate goal is simple, to boost productivity and accessibility. And I want to stress this last part, for users of all skill levels. Think about novice users. They might be new to OpenShift itself or are migrating from a legacy platform. They are often the least confident and need more help than seasoned users. As a result, they might also be generating a lot of internal support tickets. Instead of getting stuck, OpenShiftLightspeed provides them with a detailed how-to and step-by-step guidance. This doesn't just solve their immediate problem, it dramatically accelerates their skill development. But it's not just for beginners. For expert OpenShift users, Lightspeed is an accelerator for daily tasks. We all know that feeling of trying to remember a specific parameter for a custom resource, or having to jump between the console, the terminal, and the documentation to solve a problem. Lightspeed cuts through that friction. It provides quick assistance with day-to-day activity and help with complex problems resolution. So in short, it makes everyone more effective and confident when working with OpenShift. Sounds great, right? But what's the technology making it possible? Now let's take a look at the architecture to understand it better. This architecture might look complex at first glance, but it's actually a really simple and flexible design. First thing to know, Lightspeed runs on your OpenShift cluster starting with versions 4.16 and newer. And as you would expect, it's deployed via an operator. This makes installation, upgrades, and lifecycle management incredibly simple and fast. This operator manages three key components on your cluster. First, the chat interface, which is the user-facing part. That's the plugin that integrates directly into the OpenShift web console and the entry point for every conversation. At the bottom, you can find the PostgreSQL database. This is used as a temporary cache for conversations, which helps improve the quality of follow-up questions. And right in the middle, as the centerpiece of our solution, is the Lightspeed service backend. The real magic here is that it includes an in-memory vector database for retrieval augmented generation. This means that the service is loaded with the entire official OpenShift documentation and it's matched to your specific cluster version. When you ask a question, Lightspeed first finds the most relevant documentation snippets and feeds them to the AI model as context. This is why the answers are so accurate and context-aware. Now, if you look to the right of the diagram, you see the service talk to a model provider. This is where Lightspeed's flexibility really shines, as you aren't locked into a single AI model. You can connect to supported cloud providers like IBM's Watson AI, OpenAI, and Azure OpenAI. Alternatively, you can still host the model entirely within your own data center using RHEL AI or Red Hat OpenShift AI. This ensures that no prompts or data ever leave your environment, and this is key for many organizations with strict data governance or security requirements. Okay, but why not just use ChatGPT, Gemini, or whatever other virtual assistant? Well, this slide shows why a specialized tool is always better for a specialized job. First, let's talk about focus. While other LLMs allow you to ask about literally anything, OpenShift Lightspeed stays focused exclusively on OpenShift. And in a professional environment, this is a feature, not a bug. Keeping the answers on a specific topic means less tokens and therefore less money spent on non-relevant information. When it comes to simplifying OpenShift admin lives, a general-purpose model possibly can help you with OpenShift-related questions, but it's likely that the responses are useful only with big public cloud LLMs. With on-premise model, the knowledge is more limited. OpenShift Lightspeed, on the other hand, was purpose-built for this exact task. It's not a generalist, it's an expert system designed from scratch to answer OpenShift platform questions. With cluster introspection, Lightspeed can gather information from resources in your nodes and compose answers based on that information. Also, its knowledge is always backed by relevant OpenShift documentation via RAG. And that embedded documentation leads us to the next point, accurate answers. The RAG component on OpenShift Lightspeed ensures accurate and grounded OpenShift answers, compared to the general responses that public LLMs provide. Also, OpenShift Lightspeed allows us to expand that knowledge with specific documentation and internal procedures thanks to the Bring Your Own Knowledge feature. The previously mentioned RAG and Bring Your Own Knowledge components ensure that the responses are relevant and accurate for the specific environment where OpenShift Lightspeed is running. And finally, as we saw previously, if data privacy is key for you, OpenShift Lightspeed gives you the ability to choose and control which language model to use and where to host it. If you have a strict data sovereignty requirement, you can connect it to a self-hosted model running, and your data never leaves your premises. So to sum it up, while general LLMs are amazing components with a lot of potential, for professional enterprise-grade OpenShift administration, you need a complete tool that is focused, accurate, relevant, and secure. And that tool is OpenShift Lightspeed. Now it's time to see it in action. To begin this journey, our first stop will be the OpenShift Web Console. In this cluster, I have OpenShift Lightspeed already installed and ready to go. Let me show you how it's configured. If we head to Install Operators, you will notice OpenShift Lightspeed listed here. Like many OpenShift components, it's driven by a custom resource, in this case the OLS config. This is the heart of Lightspeed's configuration. Let's open it up. It is within this resource where we specify the model provider we want to use. In my particular environment, I'm using OpenAI as a cloud provider, and from the different model it offers, I have selected GPT-4 Turbo. Beyond that, we need to specify the name of the Kubernetes secrets where our API key is stored and the endpoint for our chosen model. Now, if we scroll further down, there are a couple of parameters worth highlighting. First, the introspection enable flag that I have set to true. This feature is important because it enables OpenShift Lightspeed to spin up what is called an MCP server, basically a collection of tools that give it the ability to gather real-time information from the cluster. This means that when I ask, for example, are there any pods failing or how many resources is my app consuming, OpenShift Lightspeed isn't just guessing, it's actually inspecting my cluster resources live. And that's a huge advantage compared to generic AI chatbots. Second, you can see here the RAG stanza, pointing to a custom image that I created. So this image contains internal policies and procedures that differ from the official OpenShift documentation. This is needed to enable the Bring Your Own Knowledge feature in OpenShift Lightspeed. I will demonstrate how these powerful features work in just a second, but first let's head back to the OpenShift landing page and start using Lightspeed. In the bottom right corner of your console, you will observe the OpenShift Lightspeed icon. This will be our gateway to begin formulating our queries in natural language. OpenShift Lightspeed is designed to strictly allow only OpenShift related questions and will try to avoid answering non-related topics. This is a very effective way of limiting the number of tokens used for generic questions, ensure cost efficiency and focus. For example, imagine that I'm an OpenShift administrator who has recently updated to the latest OpenShift version. My main intrigue will naturally be to find out what's new. So we can simply ask, what is new in OCP 4.19? As you can see, OpenShift Lightspeed responds by listing the latest features and bug fixes included in my specific cluster version. It's important to mention that all answers will always be supported with direct links to the most relevant documentation found in the official OpenShift docs, which were used to compose the comprehensive response. As we mentioned earlier, OpenShift Lightspeed was specifically designed to help with learning, troubleshooting, and investigating cluster resources for users across diverse backgrounds and levels of experience. For example, as a new OpenShift user, I will naturally want to know how to create cluster resources. If we want to set a resource quota, for example, we can ask something like, how do I create a resource quota for the demo namespace? And then something like, The requested resources should be 1 CPU and 2 GB of memory. Quickly, OpenShiftLightspeed provides the YAML file we requested. And here you can clearly see that the default requested resources for CPU and memory are the ones we specify in our query. Also, we can see that the quota will be applied in the namespace we suggested. So this demonstrates how we can effectively use OpenShiftLightspeed to generate resources for us. And please note, it will always provide the instructions and YAMLs we query about, but OpenShiftLightspeed will not apply anything directly in your cluster. It's intentionally read-only. So you are still in control of what's get deployed, and that makes it safer for experimentation, training, and even production troubleshooting. Now let me show you something truly cool. OpenShift also understands and can provide assistance with other OpenShift components such as OpenShift virtualization. At the end of the day, what lies behind this operator are standard Kubernetes resources that get deployed into our cluster. So OpenShift should be able to help with those too. For example, imagine I'm a fairly new virtualization user coming from a VMware background, and we have recently migrated our workloads into OpenShift. Of course, there are some terms that are not shared on both platforms, but we can still ask about them. Something like, how do I vMotion a virtual machine? OpenShift is capable of understanding what I'm referring to, and it even provides a response that shows the equivalent term in OpenShift virtualization, allowing me to follow the steps to migrate virtual machines. And that's fantastic because I don't have to know ahead of time the terminology that Red Hat uses. Instead, I can focus on terminology I'm familiar with and then learn over time. Now, let's go one step further. As a novice in virtualization, I want to create my first virtual machine. A critical first decision will be whether to use either a template or an instance type. So let me ask, what's the difference between an instance type and a VM template? And once again, OpenShift will look into the relevant documentation, encapsulate it together with our query, and send it to the LLM to provide a comprehensive response. As you can see, we get a detailed explanation of both items and a clear breakdown of what differentiates them. So now that the distinction is clear, let's ask a follow-up question. How do I create a Fedora VM from a template? You may notice that this time I didn't clear the chat session. That's because we are using a follow-up question that is directly related to the previous one. If you recall the architecture slide we saw, we can achieve this continuity thanks to the PostgreSQL database that gets deployed and temporarily stores our chat conversation to enrich the subsequent query with more context. And here's the detailed response, providing all steps to create the VM. Now all I need to do is follow the procedure described. Now let me show you something truly powerful. Let's see how Lightspeed can help us to troubleshoot issues within the cluster. As we said before, we could do this with any OpenShift resource, but just to continue with our current use case, let's exemplify this with virtual machines. So do you remember the introspection enable feature that we set in the OLS config? Yes? So that feature is what allows us to gather information from resources in the cluster. Let's see in action with the following query. Are there any VMs failing in the OpenShift CMB namespace? Here the model can decide to use one of the tools that the MCP server provides and that was automatically deployed with Lightspeed to find specific resources. In this case, it had decided to use the pod list in namespace tool to find the pods in our namespace and check their status. This is the information that was collected for the virtual machines. And here you can see the response. It looks like we have a VM that is in pending state. Let's investigate what's happening there. To continue the troubleshooting process, we can even provide more context to our query by attaching different resources. OpenShift allows you to include various YAML files and other resources depending on the object you are currently looking at in the web console. If we navigate to the Virtual Machine tab and look for our VM, we can attach different components like the full YAML, a filter one, logs, events, etc. In this case, I will provide the full YAML configuration. And now we can ask, what is wrong with this VM? We can always check the information that was attached to the question. Here you can see that we are providing the entire YAML configuration for this virtual machine. OpenShiftLightspeed analyzes this configuration file and spots the issue. In this case, a misconfigured node selector. It even suggests us to remove the node selector value to be able to schedule our virtual machine. Let's move to the configuration section, and here's the conflicting node selector. Let's remove it and see if it works now. Now all I need to do is restart the virtual machine and hopefully the issue is resolved. Cool, now we can see that the VM is starting, and if I go to the overview page, I can monitor the startup process. Great, now our VM is up and running. So this shows how OpenShiftLightspeed isn't just a passive chatbot, it's actively guiding me through live debugging sessions. Before we finish, let me show you the latest feature in OpenShiftLightspeed. Bring your own knowledge. Imagine that your team or company has specific policies or internal procedures that go beyond Red Hat's documentation. We can integrate those rules and knowledge into OpenShiftLightspeed so it responds using your custom procedures. If you recall, I had this feature enabled in the OLS config, pointing to that knowledge image that contains a specific way of setting up a horizontal pod autoscaler in my company. So now, if I ask something like, how do I use a horizontal pod autoscaler at Acme Core? Lightspeed will prioritize my internal documentation instead of the generic OpenShift docs. As you can see, the response differs from what is stated in the OpenShift docs. It mentioned that my internal policy doesn't allow me to create horizontal pod autoscalers by default and includes the step I need to follow in order to be able to scale application. So for example, opening an IT ticket and then ensure I'm using a monitoring tool. This is what makes Lightspeed so flexible. It's not just an assistant for OpenShift, it's an assistant for your OpenShift. And with that, we can conclude our journey. We have seen how OpenShift Lightspeed helps with learning, generating resources, bridging terminology gaps, troubleshooting live issues, and even integrating custom enterprise knowledge. Now it's your turn. Open your console, click on the OpenShift Lightspeed icon, and see how it can transform the way you work with OpenShift.